third session of Dash Community Call. So today we are going to talk about, we're going to have some preliminary counters that we were wanting to present. And I will share my screen here. And we also had Reshma and her team who wanted to give a talk about SAI PTF. So that's what we plan to do today. And Jai, I can present the counter screen if you like. That work for you?
Yeah, sure. Please go ahead.
Okay, great. So I'll share a different screen here. So guys, in the normal general folder design, the packet transform document, there's a section that's been empty except for a brief description called counters over the last 9 months. And I put some information in here last night, the counters that we've been going over internally and wanted to share. And so this is what we've come up with, and it's published. And Jai, I don't know if we probably don't want to go through every single one, but I have Jay on the call here to talk a little bit about them.
Hi, this is Jay from Microsoft. Yeah, we have come up with some counters for the Dash community, and I would like to go over these counters with you guys to see what do you guys think of it. This is very first draft of this counter, so feel free to comment on anything. Some of that I may not be able to answer, but I will be happy to bring it back and then get back with you for the answers. So basically, yeah, I think we can go over some counters and then see what it feels like. So starting from the beginning, I think we have the total packets. This is just the total packet from a VM exposed to customer. This we have inbound and outbound packet counters. Similarly, we have total bytes, how many bytes are sent from a VM, also exposed to customer. And then we have total unicast packet or multicast packets for IPv6. TCP connection reset have TTL. Sorry, yeah, TCP connection that had reset and TTL cut down to 5 seconds. We also have counters for that. And then non-SYN stateful, which is non-SYN TCP packets that are not dropped on. We also have counters for this, and feel free to comment if these are going to be useful or not, or if you want to add more counters in addition to what I have been talking about.
Looks like Marian has his hand up already.
Yeah, go ahead, Marian.
Go ahead, Marian.
Yeah, hi. Jay, what multicast packets are we talking about?
So VM is able to send some multicast packets out, right? We are just calculating these multicast packets.
So destination IP will be multicast?
Yeah, multicast I think has the MAC address of the multicast MAC address. I think it's 0.123, something like that.
I'm sorry, what are we talking about in multicast? We don't say multicast. For what?
I'm sorry, I couldn't really hear you, Gerald.
So what are we talking about multicast? For what service are we using multicast?
So in the past, I think we had some customers who wants to issue some multicast packets out of the VM.
They wouldn't be respected by the network. We don't support multicast. I would check that out. Our network doesn't support multicast, and so sending a multicast packet out doesn't go anywhere.
When you say our network, which part of the network?
No switch in our network supports multicast.
These are the DPU counters.
Yeah, I don't know. We don't have a multicast service. So let's look that up
Let's take a note. Yeah.
separately, because I think it's, there was a time in our network where we supported certain things like that when we had a different layer 2 network followed by a layer 3 network, but we don't build those anymore. And
Yeah,
as far as
take a
I know,
note.
we don't support multicast at all. So we'll take a note and check on that one.
Yeah, sounds good.
But this is a virtual network multicast, right? So it's not the physical network multicast.
We don't support that either. We don't have a multicast service in any of our services. So we can take it offline. I don't believe there's any such thing as multicast in virtual or physical.
I mean,
Yeah, we
an
have-
extra stat doesn't do any harm. So if somebody wants to count them, sure.
Yeah, we have a lot to get through. We have all these counters plus Reshma's presentation. So I'll take a note. Maybe we can keep going.
Continuing to number of flows resimulated. So this is when some configuration change. This is triggering resimulating of the flows. We should be counting how many flows have been resimulated because of this configuration change. Redirect roles resimulated UF. This is, I think, similar. UF means unified flow here, but I think the more correct term is a connection. We will be changing from UF, which UF stands for unified flow here, but we should be changing this to connection.
Jay, what does resimulated mean?
So when there's a flow, when there's a TCP connection, there's a flow that has been set up. It's like action match, right? From if the VM is sending a packet to another VM, there's the DPU will have an action match, like this address to this destination address will need to be maybe in-capped to some other addresses, and then this connection is set up with a flow. And if there's some kind of configuration change, like mapping change or some other changes, then they will resimulate, the DPU will resimulate the flow, so it doesn't have to go through all the matching action again, but they will just take the flow.
Actually, I think we've talked about this before. So this is a complicated thing. I don't know if I've submitted the document, but resimulation, when you do any change, it doesn't matter what the change is. Hold on a second. No matter what the change is, you have a connection table. Everybody knows what the connection table is. That's holding all our flows that were dynamically created. If you make a policy change, you don't know how many flows in that table need to be modified. You have no idea. So you actually need to resimulate the entire connection table. You have to go through it one by one. You have to see, you basically have to resimulate the flow path, to be honest, to figure out whether that connection should exist. And if anything else has changed about that connection, like the forwarding or the transformations, they need to be fixed. And so that's why you don't really want to, do one policy change and resimulate the whole table immediately. It should be done in after receiving, so many policies over a period of time. Don't know what that should be, but it shouldn't be every time you get a policy change, because you have to go through a table which is 64 million deep.
But
So
Gerald,
you don't know
Gerald,
where the flows are.
Gerald, do you have to go through that table one by one, like in a process like that, or can when the next packet arrives for a given flow, you rerun the policy on it? Like,
Well, that would mean that everything is that would be terrible. That means if you had 16 million connections, you'd be running 16 million new policies in real time, policy evaluations in real time. You'd be a dog. Like your throughput would dive. So you do it in the background.
So Jared, so this flow sheet simulation we didn't really talk about, right? In the community as a part of the requirement, is that right?
I passed the paper to one or two, but we can reissue the paper and talk about it. It's something that VFP does today, and it's something you have to do. It's not optional. And
okay,
today
then we need to talk about this feature first, right? So they introduce this concept to the community, because I'm not sure, the community fully aware of it. And let's not discuss this briefly, right? So if we want to set this as a must require feature, then we need to have a session, dedicated session to discuss is what is the scenario, why we need it, right? So those kind of things before we discuss the counter for this one.
Oh. Also, it has to be part of VNet to VNet. It's a basic function of VNet to VNet. So yes, we do need to discuss.
Sure. Then we need to, I'm suggesting, right? So, let's have a separate session to discuss that, right? So
we should do that next week because it's super important and it does take a lot of bandwidth from the DPUs themselves to do it. Any way you do it, it takes a lot of bandwidth. So we can talk about it next week. I'll have something ready in writing.
Okay, sounds good. And then we have a bunch of dropped counters, like drop packets. Is I think just in general number of drop packets that we have. Drop basket packets is dropped by some guard in the policy, and then can have some invalid packets, spoofing packets, and blocked packets. This is explicitly blocked by the policy also.
Does the drop spoofing packet mean that we have a miss on the PA validation?
Sorry, can you say that one more time?
So drop spoofing packet, does that mean that we don't have a PA validation programmed for that source IP? And it is an unknown source public address that we are dropping?
Yes.
It's like an RPF check?
So if the source is unknown, I think we are thinking this packet is spoofed and we are dropping this packet unless there's a explicit policy to allow this spoofing packets.
I guess the question is which source address are you? Customer space or provider space?
Oh, this is the customer space source.
So CA?
So Jay,
Really?
maybe more specifically from a Dash pipeline perspective, at what point should this counter be incremented?
I don't think, by the way, there's anything in our pipeline that allows you to do that.
Exactly.
If you look at the rules, rules are an ANDed list of many destinations and sources. You don't know which one. It only takes one to make the rule positive in each of the buckets. And so in the end, rules cannot tell you that. If it passes or fails based on long list and end functions, right? And after that, you do forwarding and transformations. There's no notion of, I know which source addresses are part of my VNet and I check that to see if it's valid. Like there is no check like that.
No, Gerald, I disagree with that. We explicitly put that kind of table for checking PA.
Where are you getting the information from?
From the CA
I don't
to
think
PA
there's.
mapping.
Okay, let's check it. I could be wrong. I'm not aware of that. We'd have to make sure that's plumbed, because the only way you could have got that information is somebody built the table. Because it can't be learned.
It is from the controller, I thought. The CAPM mapping table.
Okay, let's check that, make sure that it exists. If it exists, that's fine. But that's also another lookup that needs to be added into the pipeline.
Right. And what about the ENI lookup? If it fails, will it become part of this counter? If there is if we are just forwarding the packet when there is no match with the ENI?
I think
or is it related to
we
draw?
have no ENI match counter.
Okay.
Yeah, if you scroll down to the end, I think we have no ENI match.
Okay.
But yeah, I think we maybe it might make more sense to add the drop prepend in the no ENI match also, because they will be dropped also.
Yeah, that would be a good one to have for debugging, for sure.
I just wanted to make kind of a meta comment here. I think it would be a good idea that someone try to put these counters in the P4 model code to find out if there's a major discovery, surprise, or mismatch. Because sometimes these look good on paper, but then you try to get to the pipeline, you realize there's a technical problem or an inconsistency or impossibility. So just as a reality check, we ought to set a goal to do that at some point in the not too distant future as kind of part of the review.
Took a note.
Okay, thanks.
Okay, and then we have some other job packets. TCP connection by reset. A TCP connection reset by injected reset. I think this is. I think the VM injecting the reset packet for TCP connection, but actually I'm not 100% sure on this one. I'll actually get back on better description with this. We have more job packets here, redirect packets, PA discovery packets.
I think you remember we're not the endpoints, so counting the resets for that are received on ENI for its connections, it's pretty useful, because if somebody's phoning in and saying, hey, you know, I lost connections or whatever, at least we know that resets were sent. And resets are usually a panic thing, right? So I think that one is very useful. But always remember, we're the in-between guys. We're like in the middle. We're not the point, so we're just monitoring things. That one sounds super useful for debugging.
I see.
Could you repeat that, Gerald? I was trying to take a note and I messed up.
I'm saying that, remember, we are a bump in the wire. We are not the TCP endpoints. So what we do is we monitor things and we keep connections open so that they can go through, and then we close them. But we're not the endpoint. But what is super useful is if a customer is having issues where they say, hey, you're losing connections and I don't know why, at least if you have a reset counter, that tells you that, hey, you know, we know that at least we were receiving a lot of resets at that point. That would come from the endpoints, but it's useful information. At least we know that there was a bunch of connection resets done. And so that's why it's useful, because we can then go look at the endpoints and we can see, why that's happening. But at least you know that connections were failing at that time frame, and they're failing properly because the endpoints did a reset.
Got it. Thank you. And I know we can't go through every single counter here. I think we'll have Reshma pick up at 9:30, but keep going, Jay. Pick out any you specifically want to look at.
Okay. And then we have this.
Can I ask one question? Because we briefly went over those. I don't think there is any definition in Dash community of PA discovery.
Okay.
So I don't know what dropped PA discover packets mean. And the same goes for redirect.
There is a redirect happening in the ILB. That's how ILB works. You basically go to an SOB, and then the SOB sends a redirect in both directions for ILB. And
right, but ILB
you
in
need to be
general
able
was
to-
not yet. ILB
Yeah,
in general was
but-
not yet. I suspect
but it will
it's.
come. Yeah, that's where it's going to come. I'm just saying that's where that counter. So when you're doing DNet, you're not going to see that. But as soon as you do ILB, which is part of DNet, but it's like a future work for us, then you will see that. You will see for sure. I've seen P redirect.
Also dropped
And you'll-
frag packet, right? We thought that fragmentation wasn't going to be
It's
applicable.
a future consideration. It's a future consideration. We're not doing it right now.
Okay.
Correct.
Which one, Reshma?
Fragmentation.
Sorry, frag.
Okay.
Yeah,
Oh, okay.
that one. The dropped frag packet.
Okay. Yeah. Yeah. Got it. Just making a note that it's future. Okay. So did that answer Marian's question then about the PA discovery? Is that a good enough answer, Marian, or do we need to go back and
No,
research it
No, we
more?
talked about
That's
redirect. PA
PA
discovery is
Yeah,
another one.
Okay.
Honestly, I don't even know what that is. So somebody else will have to answer that question.
Okay.
Yeah, we'll get back to get back with some answers about PA discovery. I also don't have a clear idea on what this packet does. Anybody else have a question on the counters that is being shown on the screen right now? Or,
I have a question. Like, so these are like a set of defined counters that are per ENI, but there are other counters per ENI, right? Like for, like the route entry can index a counter, maybe even the ACL ACLs can index counters. Am I correct on that? And like it would be useful to understand like what the scale of those would be. So that we understand like how many total counters we need per ENI.
Right.
Yeah, Gerald, do you want to repeat?
Yeah, is there a public pool that you can use or a pool that is resource carved to at least attach them to a route entry or an ACL entry or a bucket? Yeah, definitely useful. Also, one other question I have is, do we want any sense of direction on any of these counters in and out or RxDX, or are they all global counters?
I think I wrote that up here. Counter. Sorry, I'm just reading. I thought it
needs
was
to be.
future.
It needs to be per direction for sure, guys. I mean,
Yeah.
there's a whole there's a whole set of rules on the ingress, which can be different than the rules on the egress, and the transformations are different, the forwarding is different. So you need
Yeah,
it in both
inbound and
directions.
outbound. Inbound and outbound through the civic flow, the counters increment and track separately for the inbound and outbound. So that's here. Does that help?
Yeah, I think that's clear. I think that,
Okay.
I don't know who mentioned it, but I do think that we should be counting how many times a rule was hit.
Right.
Maybe forwarding, I don't know, but we should, Christina, have another meeting on like the pipeline itself. What counters do we need from the pipeline directly?
Mm-hmm.
We should come back with that.
Right, like I thought that there were counters like associated with billing, right? Like these counters seem to be associated with just debug and overall status, but like I thought that there was a whole nother set of counters like associated with billing, depending on like where the traffic is being routed. There are different counters that have to be incremented.
That is correct.
Yeah.
If you're staying within the region, it's one.
Right.
price. If you're leaving the region, it's another price. If you're, using a special server, like this server, for example, is another price. But yeah, so you're right. So we should, if it's not included in these counters, we should review what are the billing counters that.
And so the billing work is happening right now, John. James Grantham's team is working to try and define that.
Okay.
So we're on it.
Yeah.
Okay.
Okay, yeah,
Okay.
this is just the first swing of what we had right now. I'm wondering if maybe could we go back with our questions and maybe let Reshma do her presentation now and wrap this up, and maybe if there's more questions, give me some issues or PRs against it, or email me and I'll do it, something like that. Or do we want to talk about this for a couple more minutes?
I think we can do reference, but make sure that if you guys just send out the questions, Christina, and let people respond. Hey, I mentioned this one. And just make sure we collect all of them.
Yeah. I'm definitely taking notes, and I know you guys have been asking, so this might not be perfect, but it's out here, so we'll keep working on it. And if you have any advice, please give it to me or give it to us, me and Jay. Okay, I'm gonna stop presenting, and Reshma, do you want to go ahead?
Yeah, sure. Thank you, Christina.
Okay, and thank you, Jay.
Yep.
Vladimir Mitnick, would you like to present? Hi everyone, I think we have discussed it a few times earlier, but just a quick recap is that Intel has developed a Python test framework, test harness, and has upstreamed it to OCP SAI. It's an auto-generated Python-based data plane testing framework. It creates the Python wrappers around the SAI functions automatically so that the test case can be written with much more ease and hides the RPC, etc., which we'll go into a little bit at the beginning. For Dash, we have been adapting this framework to work with Dash devices with fewer ports. And a lot of test cases that we have also have been adapted to the Dash use case as well, and the Dash device mainly. In today's demo, we'll be showing this test harness working on Dash device, real hardware, the Intel IPU. So yeah, please continue to the next slide, Vladimir. Yeah, please continue, Vladimir.
Yep. So hi everyone. So yeah, today, as Rasmus said, we are going to talk about the running PTF test on IPU. First of all, the brief overview of the PTF and our SAI Swift server and client. So we already presented what it is and how to generate automatically the SAI server and the SAI client from your SAI library. So here we just put some brief explanation of what is happening here when you use the generation framework. And yeah, so for this demo, we prepared like a few scenarios, very short scenarios, and to run on the IPU. So we are going to show the NCAP and NDCAP, the scenarios in case of the VNet use case. And also we are going to run everything using the PTF test case framework. Also, we will run everything on the APU, and also at the end we will show the one simple stateless ACL example at the end. So for today's demo, we prepared the simplified setup just to show this use case. So we have the host and we have the test controller, or let's say client, running on the same host inside the Docker container. Also, we have the SAI Swift server, which has been generated using the auto-generated scripts that we just discussed before. And also it is linked with the IPU libSAI, which uses P4SD to control the IPU. Yeah, and the flow from the PTF framework, or let's say from the test case to the IPU, and from the IPU is explained here. So the first use case is the inbound traffic. Yes. Yes.
Would you like to show the other diagram, how it maps to the PTF framework itself, the diagram in the document, the PTF server where the RPC server is and the client is?
Yeah, maybe I will just show our, okay. Yes. So this one, right? This diagram.
No,
this
no,
one?
I think you're showing the wrong one, the document, the detailed design.
Oh, yeah, okay, yes. Here, this one. Yeah, so this the official documentation which is already on the SAI repository. So there is explanation about how to generate the SAI server and the client library to be able to use for your test cases. So on the right side, build in our case it's Intel IPU card, so we have the libSAI there, and also we have RPC generated server which is running also on the IPU, and we have auto-generated the SAI Swift client, which is used by our tests to run the test case itself. So this is the official documentation, so everyone can go and read in more details how to run it. And
yeah, just want to show how this maps with your software components diagram.
Yep.
Thank you.
So yeah, so this is absolutely, let's say, aligned with what I showed on the official SAI PTF documentation. So on the right side we have the SAI Street server, and on the left side we have the client and the PTF framework, which have the test cases, which uses the SAI Street client to execute the exact test case scenarios. Okay, so let's move on. So for the inbound, let's say, traffic flow scenario, so what we will do, we will configure the inbound rules on the IPU using the auto-generated Python-sized Swift client APIs. We will send the VXLAN packet to the network to host direction with the VNet header. We will check that it matched the ENI, otherwise it's dropped, and check the packet is matched our source IP address P, and otherwise it will be dropped, and then we will ensure that the packet matching inbound routing is decapped. And this is the details, packet details, what is happening during this use case from the right to the left. So we are assigning the VXLAN packets to the physical interface, and it goes through the IPU through the configured tables, and then it goes out as a decapped if it will be matched the ENI and PI validation tables. And let's go to the scenario itself. So on the left, right, we see the SAI repo with all changes we already did for the PTF. I mean that to be able to run on the devices with the fewer ports. And on the right top corner, we start the SAI server. Okay, so it starts listening on the port 9092. On the bottom left, so I start the TCP dump on the one of the ports where we will be sending the traffic. And on the right bottom, so we start the TCP dump on port where we will receive the traffic. Okay, let's go back to the SAI PTF and let's run the inbound test. So before running the inbound test, I will show the test case itself. So we prepared for this demo test case. This is the PTF test case, which uses the new class, which it can be used for the dash. Okay, so we are using just the 2 ports. So we're defining the direction lookup, ENI, IP validation, source IP. And also we we creating the VNet configuration, which is described over here. So like deep, so direction lookup, like create a DNI, we creating the DNI to MAC mapping, creating in-band routing with a dcopy validate action. And then what we do here, so we set up everything and we sending the VXLAN packet with the invalid destination MAC address, with the invalid PE validation IP, and then we're sending with the VXLAN and expect that it will be decoupled. And if we go back to the console, so let's start the test case. So I added the PDB traces just to stop the test case and show what's happening a little bit. So on the right top, we saw that that hardware had been programmed with the correct values based on our configuration. Then we sending the packet that with the invalid destination MAC on the left. Yeah, MAC address on the left. So the packet has been sent, but nothing has been received on the right. Then we send the packet with the invalid PA configured. It also has been sent, as you can see on the left, but nothing has been received on the right. Then we send the packet correct one, and we expect that the packet has been decoupled based on our configurations. And then, yep, excuse me.
I just said that was cool.
Okay. Okay, so let's go back to the next scenario. So it's related to the outbound traffic scenario. So we configure the outbound rules. We use different setup. We send the packet, decoupled packet to the NIC itself, and then with a VNet 1 in our case, and then we check that the packet is encapsulated based on SAI PTF mapping configured in the test case. And again, this is the packet details, what is happening with the packet from the left to the right. So we send the IP packet without the encapsulation, then it goes through the IPU. We have the SAI PTF mapping table here, explained over here, and then it goes with the VLAN tag, which is also presented on the right. Yeah, and let's go to the live thing. So I'll just scroll out a little bit. Outbound test case. So once we start, the configuration will be applied. And on the right bottom, we observe that we programmed the device through the libSci and site-street server. And if we go to the outbound test case, so we decided to use absolutely separate test case for the inbound outbound. So again, we configure like direction lookups here. And let me go next. Yeah, so we creating the underlay routing for us, just to populate the MAC addresses correctly, and configuring the neighbors. And we also configuring the direction lookups and ENI, creating ENI mapping, outbound, ENI, VNI, and outbound routing, and SAI PTF entry, what we are testing today with this IP address. So if we back to the console, so configuration has been applied. So right now we are going to send the traffic, and we expect that it will be encapsulated based on our tables. So let's continue. And as we observe, so from the right to the left, because we send traffic now in the opposite direction for the previous use case. So we send the IP package, and on the left we observe that the packet has been encapsulated with the correct values, like the MAC address of the router interface with the neighbors, and destination MAC address with the VNI number 2, as explained on the slide. And it was for the outbound. So we have the test case. So it's just a regular stateless ACL, you know, so we can just demonstrate that we can, you know, just deny or permit the packet. So we implemented just simple DMARC matching here. So what this test case is doing, for now, we send the packet before anything is configured on the device, so nothing is received. And then we will send the correct packet with the right destination MAC address entry like here. And as we can see from the left to the right, we send the packet and received on the right. And if we right now we are sending the packet after the entry has been removed from the device, and the packet has been sent, but nothing has been received on the right. Yeah, and the test case has been passed, so everything is okay here. So I'm done. If you have any questions, so please go ahead.
Oh, that's great. I have a few questions, if I can ask.
Yeah, Chris.
First of all, it's awesome to see it running on a real piece of hardware. Well done.
Yeah. Woohoo.
Yeah. Does the SAI API that you generated correspond, match pretty well to the BMV2 P4 model in the Dash repo? It's the same tables, the same elements.
It's the same tables that we had described in the HLD, so definitely it will be matching with the BMV2 as well, for the most part. Yeah.
I guess more concretely, could these test cases be leveraged in the BMV2 model on Dash? Exactly.
Great. Yeah, so we generated the RPC based on the external API that we have in the community today.
Oh,
so
good.
It's absolutely aligned with the BMV2, so yeah, you can take it and run it.
Do you think we can try to get these running in the BMV2 model? Some of these, the ones that you know, the BMV can support?
It depends what BMV2 supports, but we can run, of course.
I think we can use, as much.
I think it would be a good litmus test as to how ready the behavior model is, right? You have a real piece of hardware. Does the model live up to at least a subset of it? So I think this is really good to have a proof point like this. I mean, very good.
Yeah. So this test is doing not a lot of, let's say, the validation stuff in contact with the VNet at this moment. So we can use a starting point and then update it, you know. But for the beginning, we can use it for sure.
Would these test cases be submitted to the SAI Dash branch, or are these kind of offline right now?
No, it's offline right now. So we are planning to upstream it.
The test case, right? Yeah,
yes.
The test case is very new, and we have just tested it, and we plan to upstream it for sure. We can actually add it to our Dash branch, where the rest of the PTF framework is already upstream to the Dash branch. We can just upstream it there and have you take a look at it and everyone, and we can enhance it together as well in the community.
Yeah, I think we're at a really good point here where last night I wanted to mention to the group, we merged my pull request for the SAI Thrift framework for Dash. And that means we're ready to now get your Dash branch of SAI kind of harmonized with that. And then we can have the best of both worlds, right? We could actually pull in your SAI branch into Dash and use these tests because they're already going to be part of that repo, right? So we can hash out the details offline from this working group, but I think we're ready to try that next. That'll be great.
Amazing, you guys. That's awesome. Very exciting.
Yeah, this is Prince. It's really great. So Reshma, I have one question. So these test files, right? The thrift test files. Maybe I missed where you're planning to upstream. Is it to the SAI or?
So yeah, the final destination will be SAI. At this time, what we have is a separate, branch under Dash, where we have all the changes that we have done for the Dash related changes that we have done for the auto generated test framework. it's already there under Dash, so we can all collaborate and work on it together, and especially for Chris's work, etc., and anyone in the community who'd like to use. But as we complete that, and whenever we think the enough number of test cases are also upstream there, we can actually bring it all into actual into OCP SAI.
All right. Okay.
Yeah, and Prince, to that point, the way that the SAI thrift framework is for Dash right now, it actually pulls in a branch of the SAI repo. It could be a fork, like Intel's fork, or it could be the official upstream one. It doesn't matter. At any point in time, we can be using development branches like this, and all the test cases are sucked right into the Dash repo, so they can be used. So it's already kind of set up to be convenient. There's no copying or adapting. It's linked right in as a submodule.
Yeah, it's linked as a submodule.
So for the SAI API, are we bringing in all those, the header files from the experimental directory for this purpose?
Yes.
Okay. Thanks.
Yeah, you showed some underlay kinds of setups, like underlay routing, which isn't part of the Dash behavioral model. So there's some differences that we'll have to sort out, right?
In the sense behavioral model, but yeah, for the VNet use case as well, there is some amount of routing that is needed. That's the part we were setting up in our test case that Mitnick has shown as the underlay part.
Yeah, probably in the behavioral model meeting, we'll have to hash this out a little bit and decide how to bridge the gap between the Dash behavioral model and a full-blown implementation like the one you just showed, so that we can still run test cases even if we don't have, say, all the underlay tables.
Yeah, sure, we can discuss. Yeah, sounds good.
So once we have verified this one on BMV2, could we make it part of the CI/CD process as well?
Yeah, that was our next thing that we were going to also discuss. We have this discussion with Chris and Keysight and the CI/CD. Maybe if you want to show the diagram, Mitnick, it may be more easier to visually see how everything fits together. But definitely, we have plans to integrate with CI/CD.
This one, Rashma?
Yeah.
Yeah, so as you can see here, yeah, so we have like the PTF or unit test framework running. This is what we show today on the left, which is using the PTF trophy gen, but we also has some example that Chris is using, for example, PyTest using the Snappy. So this is what we have today. So everything, both of them can be used on the CI, right, Chris?
Yes.
So we can run it.
Yeah, so you could actually run Snappy in the PTF test, which I demonstrated that over a year ago. And so we could do flow-based testing, where it's more interesting to have large numbers of packets with patterns in the header fields, etc. And then also the single packet at a time type test that PTF is excellent at, and have both. So I think it'll be fun to combine these two techniques.
Yeah, I agree.
Awesome. Any other questions for today? Or Gerald, what do you think?
No.
I think we can give 9 minutes back. That's fantastic work, Reshma and team. Thank you so much.
Thank you.
Yeah, amazing. Then I'll go ahead and stop the recording. I'll post it